Function composition. What's 44? 44 is g of x times f of x. So it's literally take 2x plus 3 and multiply it by 5x squared minus 3. And then you would FOIL. 10x squared minus 6x plus 15x squared minus 9. Easy stuff. If I didn't make a mistake, 10x cubed, right? Looks right. In STD form, 10x cubed plus 15x squared minus 6x minus 9. The domain, that's x to the odd. X to the odd looks like this. Maybe you can see my hand. Starts low, ends high. Runs forever left, runs forever right. It's negative infinity to positive infinity. If you don't believe me, you know, the only thing that actually matters is that. That's what we call the power function. Maybe you remember me talking about power functions. And I need to turn inequalities off. I need this to be an equal to symbol. I had been playing with this calculator earlier. Actually, I just need to turn this app off. Second apps. Get out of this. Because this might end up in a student's desk and I've completely screwed it up. There we go. You may remember earlier I was playing with it. The most important part of that function is 10x cubed. And if you just look at its graph, I know you only see a 10 by 10 window, but it is slowly going to run left and it is slowly going to run right for all of eternity. If you don't like interval notation, then you can say something like this. Set notation. All values of x such that x is an element of the real. It's up to you. Pick your poison. Red pill or blue pill. They both gonna hurt. 45 is basically the exact same thing. It's just different notation. This is literally f of x times g of x, which we did. We did it right here. We just swapped it around. So it's the same blasted thing. It's still 10x cubed plus 15x squared minus 6x minus 9. That was the point. Understand that notation. And the domain is still the same, negative infinity to positive infinity. Or, if you like set builder notation, all values of x such that x is an element of the real. All right, 46 is got a plus symbol. That is literally f of x plus g of x. What a horrible looking g. I'm going to write it out. Then I'm going to put it in STD form. That is 5x squared, which looks like a parabola. If you don't believe me, you can either graph the power function or just part of it. But all that really matters is the power function. But anyways, you probably don't believe me because you're young and dumb and don't trust a word I have to say. Runs left forever, runs right forever. Negative infinity to positive infinity. Or, set notation, all values of x such as x is an element of the real. 47 is going to be a rational function, f of x divided by g of x. That's 2x plus 3 sitting pretty over 5x squared minus 3. It is going to have some limited domain. It is going to have what we call vertical asymptotes. I don't know that TI-84 can show them, but they're going to be at whatever the square root of 3/5 is. There's going to be some places this graph just can't touch. There's two rules about domain. One of them is square roots, and the other one has to do with dividing by 0. It's kind of a rule. It says thou shalt or shall not divide by 0. So 5x squared minus 3 cannot be 0. 5x squared cannot be 3. X squared cannot be 3/5. So x is not plus or minus 3 root 5 over 5. It's everything else. All right, and we'll take a look at the graph so you can see that. This thing also has what's called a horizontal asymptote, which is not something we've talked about. What was that? That was 2x plus 3. Math, number, numerator over denominator. You see what's happening on this graph is here and here we're jumping. We're jumping over what's called a vertical asymptote, which TI-84 cannot draw. All right, but they're there, and their values happen to be right here. So this is the function. The domain's a lot harder to write out. What we do is we come in from negative infinity, and then we hit that negative, I don't even know what I wrote, negative 3 root 5 over 5. We jump it. We jump to the other side of negative 3 root 5 over 5, all the way to positive 3 root 5 over 5. We jump, and we move on to 3 root 5 over 5 to infinity. It's got 3 pieces of its domain. You have this piece, where x's are valid, you have the stuff in the middle, and then you have the third piece. There's 3 pieces of its domain. Set builder notation, way easier on this one. All values of x such that x cannot be plus or minus 3 root 5 over 5. It can be everything else. All right. So we have 3 functions given, f of x, g of x, there's an ant there, and h of x, and you're asked to find some things. You got f of g of negative 3, which is something you've been doing in your basics quizzes. This isn't new. Did it last year. This is literally f of this is f of g of negative 3. So I'm going to plug a negative 3 into g. G of negative 3 is a negative 3 squared, which is negative 9. And now I'm going to plug a negative 9 into f. And that's going to give me negative 25. Moving on. G of h of f of 8. So you got to start by plugging an 8 into f, then you got to plug it into h, and then you got to plug it into g. F of 8 is going to be 3 times an 8 plus a 2, which is 26. Sounds right, doesn't it? Yeah, 26. Now you're going to find h of 26, because we're working our way out. That's going to be 26 plus 2 over a 3. Yeah, it's kind of 28 thirds. Doesn't reduce. And now you're going to find g of that. You're going to find g of 28 thirds, because again, you're working your way out. It's negative 28 over 3 squared. I'd love to tell you I know off the top of my head what 28 squared is. I do not. So that was negative, parentheses, 28 over 3 squared. Math, enter, enter. Negative 784 ninths. Just like the movie Inception, g of negative 5. Again, work your way out. G of negative 5 is a negative 5 squared, which is negative 25. So now I find g of negative 25, which is a negative 25 squared, which is negative 625. 81. H of negative 4. H is that fractional function, isn't it? So h of a negative 4 is a negative 4 plus 2 over 3, which is negative 2 thirds. And then it gets ugly, because now I got to find h of a negative 2 thirds. Well, that's negative 2 thirds plus 2 over 3. This isn't so bad. Negative 2 thirds plus 2 should be 4 thirds. This is 4 thirds over 3, which is 4 ninths. I don't know if you remember the rule, but I've taught you you can move a denominator to another denominator. And, if you don't believe me, you can, have faith in your TI-84 that it's as smart as Mr. Milbrath. Sometimes it's smarter. 4 ninths. I know numbers, but I'm not calculator good. That's what calculators do. F of 7. F was the easy function. It's 3x plus 2. So f of 7 is 3 times a 7 plus a 2, which is 23. Now I'm going to find f of 23, which is 3 times a 23, add a 2, which is 71. There's my answer. H of f of g of 2. Look at that notation. H of f of g of 2. That is, I'm going to rewrite this. H of f of g of 2. That way you can see clearly the goal is to work your way out. So start off by finding g of 2 and then plugging it back in. G of 2 is a negative 2 that is squared, which is negative 4. F of negative 4 is going to be 3 times a negative 4 and then add a 2, which is negative 10. And then I can find h of negative 10 by plugging in a negative 10 into function h, which is negative 10 plus 2 over 3, which is negative 8/3. Fun stuff. And there's more. Yes. All right, let the root of 6x minus, let f of x be the root of 6x minus 3, and then g of x is 2x minus 5. Find and state the domain of. So 54 is f composed of g of x, which means that everywhere you see an x, it becomes 2x minus 5. This is the root of 6 times 2x minus 5 minus 3. There you go. I plugged it in. Do the math. This is the root of 12x minus 33. Now, it's not on your form quizzes, but it has to do with domain. The root of anything, I don't care what it is, the root of anything, we'll just use letter A must be greater than or equal to 0. Has to be. Because if you start taking the square root of a negative, bam, it's imaginary. Got a hand cramp, sorry. So 12x minus 33 has to be greater than or equal to 0. 12x is greater than or equal to 33, and x, which is my domain, by the way, is greater than or equal to 33/12. And I'm just going to go ahead and write that out as set builder. Or I can use interval notation. I could be 33/12. I need a bracket there, don't I? To infinity. Because I had equality. 55 is g of f of x. So when I write g, I see a 2. Now I see an x, and it's going to become the root of 6x minus 3. And then take away 5. And I still follow that same rule. The root of anything, whether it be a smiley face or a frowny face, it doesn't matter. It's bigger than or equal to 0. So this is the issue. 6x minus 3 is greater than or equal to 0, and that gives me that x is greater than or equal to half. So if I like set builder notation, all values of x such as x is greater than a half. If I like and love and not loathe interval notation, I'd go from a half to infinity. 56 got that division. Division makes things more complex. It is f over g is the root of 6x minus 3 over 2x minus 5. And there's two rules. There's this dude, and then there's the previous rule that I wrote on a different page. Right there. Thou shall not divide by 0. It's on the 10 Commandments too. It's an abomination. It's the second commandment of math. So anyways, I've got this piece from earlier. I know that x is greater than or equal to a half. And then I've got this piece of information. 2x minus 5 cannot, shall not, will not be 0. X is not 5 halves. Well, there's no contradictory statement there. You just write your all values of x such that x is greater than or equal to 1/2, but x cannot be 5 halves. It's a little harder to write out the interval. It's not that much harder. We start at a half. All right. We get to move to 5 halves, and we have to jump to the other side of 5 halves and move on to infinity. Then we got 57, which is g over f. That's 2x minus 5 over root 6x minus 3. Now, because of the location of this radical, I have to drop the equality symbol. 6x minus 3 has to be more than 0. I can't say it can be 0 because then I'd be dividing by a 0. So x is greater than a half. All values of x such that x is bigger than a half. Or, parentheses this time, 1/2 to infinity. And the next section is about inverses, which is a different topic. So stop this video. I've got a few more minutes to do another one. At least I can get started on it.